Hi guys, my name is Trevor Sullivan. Welcome to another video on my channel. First of all, if you haven't yet, please click the subscribe button on my channel so you get notified for all future videos. And I would love it if you guys would comment and let me know any feedback you have about my video content, the format and style, and also if you have any ideas for future video content. I'd love the ideas. It could be PowerShell related, could be cloud related. I'm open to pretty much any ideas, although I do have limited time to do all these types of videos. So feel free to leave any comments in the section below and just engage in any type of feedback, and I'm always happy to respond if you have questions. I can't guarantee answers to every question, but I'll do my best certainly as well. So let's go ahead and jump in today's topic. So what we're going to do is we're going to fire up Visual Studio Code. We're going to look at a couple of useful extensions for VS Code, and then we're actually going to jump into the main topic, which is how to register for file system handlers. So I've got Visual Studio Code installed in front of me here, and I'm going to hit Control-tilde to open up the PowerShell terminal inside of VS Code. And then I would like to draw your attention, if we hit Command-Shift-X on the Mac keyboard here, and take a look at some of the extensions that I have installed. The first one is the PowerShell extension. And the PowerShell extension is great because it gives you syntax highlighting and debugging functionality and a bunch of other capabilities within the Visual Studio Code environment. I also have the Docker extension installed, and this is a extension that's developed and published by Microsoft, and it gives you this nice little Docker capability in the activity sidebar here that provides you a list of containers that are currently running on your local system, a list of all the images that you have pulled from Docker Hub or anywhere else for that matter, or even if you've built them locally. So right here I've got the Microsoft/PowerShell image, and you can see the individual image tags that I've actually pulled. So I have the preview version, which is currently the version 7 RC2, and then I have the latest, which is the one we're going to be using for this demonstration, which is PowerShell version 6.2.4. And then it also shows you any custom Docker registries that you might have configured, which you can pull and push container images to and from, Docker networks, and Docker volumes as well. So the Docker extension is really nice. It also helps you to author Docker files as well, so that's pretty cool. And then the third and final extension that I wanted to bring your attention to, which is going to be important for today's video, is the remote containers feature, or extension rather, which is again published by Microsoft. So all three of these extensions that we're going to be working with today are written by Microsoft, and so they're really cool development tools. What's nice about the remote containers, and you'll see here in a moment how it works, is that you can basically create a new container and connect your Visual Studio Code environment to that container, and everything that you do inside of your VS Code environment that's attached to that container will be isolated within that container. So you have kind of consistency guarantees around, being able to spin up a fresh container every time that you run tests and ensure just the consistency of that environment. And you also avoid any conflicts with any local system dependencies you might have installed. And it gives you the flexibility to use different languages. So if you're doing some Python development one day, you might want to use a Python container, or if you're doing PowerShell development, you might switch over to a PowerShell container instead. So this is a really great extension as well. So the next thing I want to do is point you over to the previous video I did on PowerShell remote containers as well. I do have a video that's dedicated to that topic, and I have a library of other PowerShell related videos, so please feel free to check those out. Also, if you go out to the Visual Studio Marketplace, there are landing pages for each of the extensions that we just reviewed. So there's the PowerShell extension, the Docker extension, and the Remote Containers extension that we just looked at. So you can install those directly from VS Code, but you can also get more information and get links directly to the GitHub repositories for each of those extensions right here on the VS Code Marketplace. Okay, so the next thing we're going to do is take a look at the Docker Hub here, and this is where I actually pulled the PowerShell container image from. So what we're going to do now is actually switch over to our terminal on Mac OS here. So I'm using iterm2 here, and what we're going to do is start by pulling the Microsoft.PowerShell or Microsoft/PowerShell image. And so by default, Docker is going to use the latest tag. So what we're essentially doing is doing docker pull Microsoft/PowerShell latest tag. And sure enough, I have the latest one here. Now, just to give you a little frame of reference here, I am using the Docker Desktop tool here. So if you're on Windows, just download Docker Desktop for Windows instead. And what's nice about this is that it automates the process of setting up your Docker environment, which is basically just a Linux VM that's running behind the scenes. So on Windows, it runs on Hyper-V. On Mac, it runs on the Xhive hypervisor, which is built into Mac OS. And on Linux, you can just run Docker natively. So there's no need for a virtual machine. I'm not quite sure how Docker Desktop works there. In fact, I don't think they have a Linux version now that I think about it. So anyways, the first step to get started here is we need to spin up a fresh PowerShell container. And the way that you can do that is either using the Control-tilde terminal here in VS Code, which is running PowerShell, or you can just do it in your native OS terminal as well. So what we're going to do is do a Docker run, and then we're going to do interactive --tty, and I always do this as a best practice. You don't strictly have to specify these two parameters, but I like to do it personally because if I ever need to attach to a container and interact with that container and use the stdin and stdout streams, then this allows you to do a Docker attach command to that container later on and get that interactive environment. We're not going to be using the container interactively in that manner for this particular video, but I just always like to do it as a best practice. And then the third parameter we're going to add here is detach. So we're basically going to say run this container in a detached mode, and if we want to attach to it in the future, we certainly can do that. And the last parameter here is just the container image that we want to spawn a new container from. So that's going to be the Microsoft/PowerShell container image. So what we get back here is just a new unique identifier for the container that started up. If you want to verify that the container is indeed actually running, you can just do a Docker PS. Sure enough, it is running. You can also switch over to Visual Studio Code, and if you switch over to that Docker item on the activity pane, the activity sidebar, you just hit the little refresh button up here and you'll see a list of all the containers that are currently running on your system. So this represents the single container that's currently in a running state, hence the little play button there, play icon, and it basically tells me how long it's been up and running for. You can also right click on it and get the logs, you can attach to it, you can attach VS Code to it, and you can even stop or restart or delete the container from your system if you'd like to from here. But what we're going to do is we're going to use the Command-Shift-P menu here, our command palette in Visual Studio Code, which is one of my favorite features about software user interfaces in general. I love the notion of having a command palette that I can just search for whatever command I need to run at that particular moment from any context. And what we're going to do is search for remat, because I like to type as little as possible. We want to use the remote containers extension, and specifically we want the attach to running container feature. Now, when we hit enter on that, we're going to get a list of the running containers on our local system. Right now, we only have the one PowerShell container that we spun up over in iTerm. So if we hit enter, we're going to actually get a new VS Code window spun up here. And you'll see in the bottom right of the screen, it's actually doing installing dev container. And what that is it's basically the software package that has to be installed into your container environment for the VS Code remote containers extension to do what it does. It basically attaches VS Code to that remote container and allows you to interact with it almost as if it was local. So now that it's finished running the installation of that dev containers package inside of our container, on the bottom left here, you can confirm that we are in fact attached to that container by the little status bar icon here, or status bar, dealy bob, whatever you want to call it. All right, so now we've got our container environment running. One thing I'd point out, if we do Command-Shift-X, now that we're in a separate VS Code window that's attached to the container, you'll actually get a list of extensions that are installed locally on your system. So this is what's installed on my Mac OS system. And then here in the middle is a list of extensions that have been installed for VS Code inside of the container specifically. So as you'll see up here, some of these extensions that I have installed locally on my Mac actually have an extra button next to them that say install into the container. But it's automatically installed the PowerShell extension for me, so we are good to go as far as extensions go inside of my containerized environment. All right, so now what we're going to do is start by taking a look at the real source of today's video, which is the FileSystemWatcher. So if I go ahead and switch over to this FileSystemWatcher documentation, the FileSystemWatcher is a class definition that's in the .NET framework. And as you'll notice, it's part of the .NET standard as well. So we do have that available on the cross-platform version of .NET. It's not exclusive to the Windows version of .NET. So we can actually use FileSystemWatcher on Mac and Linux just like we do on Windows. So the FileSystemWatcher class is pretty simple to use. This is a C# class definition here, but what we want to do is actually use this in PowerShell. It does have a filter property that allows you to filter down to specific file paths that you want to monitor. For example, you could filter down to star.txt, or if you're in a PowerShell project, you might want to filter down to monitoring star.ps1 files, for example. You may also be writing documentation in Markdown, so you might want to monitor for star.md files that then get compiled into a different format using some kind of build task or something like that. There's also a method we're going to take a look at called wait for changed. We're not going to use that in our kind of long-term endeavor, but it is useful for kind of testing out the FileSystemWatcher to make sure that it's working the way you expect before you actually register for all object events inside of PowerShell. So we'll jump into that here in a moment. All right, so let's go ahead and start using this FileSystemWatcher class in our PowerShell script inside of our container. So inside of my containerized VS Code environment, I'll hit Command-N to create a new file. I'll hit Command-K and then M to switch the language mode to PowerShell. So that's going to automatically pop open a PowerShell terminal that's again running inside of that containerized environment. And I now have a PowerShell file here as denoted by this icon up here in the corner. So the first thing that we need to do is actually to instantiate the FileSystemWatcher class. And to do that in PowerShell, traditionally there was the new object command that allowed you to specify a type name. So you could say FileSystemWatcher here, and then you could specify an argument list that would get passed to the object's constructor. But we're going to use the more modern syntax for PowerShell, which is to put the class name in square brackets, and then call the static new method, which essentially just calls the constructor for the class. And then we'll assign that new class instance to a variable called watcher. Now, if you take a look at the object constructor here, we have 3 overloads for that constructor definition. We can instantiate the FileSystemWatcher with no arguments, but we can also pass in a string, which is the path that we want to monitor. Now, PowerShell has a built-in variable called psScriptRoot, and psScriptRoot basically points to the path of the current file that we're running. So we haven't yet saved this file to our file system, so let's go ahead and do that now. I'm going to call this file tasks.ps1 and put it into the /root folder where I have currently mounted in VS Code here. So now that we have the file saved, if we were to use F5 to run this file inside of our containerized environment, psScriptRoot would basically resolve to the /root directory. So once you've created the FileSystemWatcher object, the next thing to do is to examine a couple of properties on it. Now, I did want to call your attention specifically to the filter property, which is a string property that allows you to set the filter. However, the limitation that I wanted to mention here is that the filter only accepts a single value. So if you were to do star.txt, you couldn't do a comma or some other kind of delimiter to specify star.ps1 as well. It's only restricted to a singular value. So we're going to take a look at a workaround for that inside of our handler. But as far as the watcher itself is concerned, that filter is fairly limited in nature. Now, there is another property I wanted to call your attention to on this object, which is the include subdirectories. So let's go ahead and hit Function F5 on my Mac keyboard to run this now. And what you'll see is that we create the watcher, and it gets assigned to a variable. And then the watcher.include subdirectories is a Boolean property that is emitted to our output here. So we get false. So including subdirectories is false by default. So if you want to watch your entire project directory for your software project, then you want to make sure that you actually change that property to true by using the equal sign true, $true. So now we've got that. So if we run that, we have a watcher, and we've set include subdirectories to true. So the wait for changed method on the FileSystemWatcher class that I pointed out previously in the documentation is useful for just starting to understand how this works. So let's do watcher.waitForChanged. And if I delete the parenthesis, the opening parenthesis, and then hit Control Space, that'll pop open my method overloads here. And you can see that I have two different method overloads. One is to watch for specific types of changes, and the other is to watch for changes with a customizable timeout as an integer. So I'm going to just specify the first method here, which requires that you pass in a watcher change types. Now, if we switch back over to the documentation here and switch to the docs for watcher change types, we can see that it's actually a .NET enumeration, or enum for short. And if you take a look at all the different supported values for this enumeration right here, we have all events, which is creation, deletion, change, or renaming events, or we can specifically request that we want to look for changed, created, deleted, or renamed individually. So what I'll do is switch back over here and specify watcher change types, : all. So if I do function F5 to rerun the script, basically what's going to happen is it's going to create a watcher, it'll include all subdirectories, and it's going to watch for all types of events. And when the first event happens, the script is going to return control back to the terminal. So you can see PowerShell is spinning down here. That basically means that it's hanging, it's waiting for something to occur to continue executing the script. So there is no line number 5, but if there was a line number 5, it wouldn't execute until this wait for changed method actually returns. So let's go ahead and just create a new file here. We'll just call it ASDF. And sure enough, we get this event echoed out to our console here. And as you can see, script execution has returned. We can now interact with that terminal down here. Okay, so that's a good way to kind of test out your watcher and make sure that it's configured correctly. One other thing we should probably test for as well is that the include subdirectories is actually working. So if I create a folder here called F1 and then rerun the script and then create a file under F1, we can now confirm that our watcher is successfully monitoring subdirectories as well. So let's go ahead and just clean this up here and get ourselves back to square one. Now, one thing I would point out as well is that if you ever run a PowerShell script that's waiting for an event like this, and in VS Code you hit stop on the debugger, sometimes PowerShell does tend to hang. So as you can see, I'm not getting a prompt here. It's not responding. Even if I do Control-C, it's not responding at all. So if you ever get into that state, a really easy way to recover from that state is just to do Command-Shift-P and then search for the PowerShell restart current session command. And if you run that, the VS Code extension will basically just restart your PowerShell session and get you back to square one, where your terminal is now properly responding. Okay, let's move on. So now that we've taken a look at the wait for changed event, the next thing we want to do is persistently wait for different types of events inside of our PowerShell script. So wait for changed only responds to one event, but we want to basically register for events to occur at any point in time, starting now, anytime in the future. So the way that we do that is using the register object event command. And this takes a few different parameters. Don't be too overwhelmed by all these parameters. All we really care about are the input object, the event name that we care about, and then the action. And the action is going to be a handler. It's basically going to be the block of code that executes when our events occur. So our input object is really simple. It's just the object, the .NET object that we want to monitor for events. And that's going to be our FileSystemWatcher. Now, if we switch back to the documentation for the FileSystemWatcher class, on the right-hand side here, we have properties, methods, and events. And if you take a look at the events that are exposed on this particular object, we have changed, created, deleted, disposed, which is kind of outside the scope of what we're talking about because that's just an object disposal. It's not representing a file system change. Error. So if we don't have access to a particular path, so if the FileSystemWatcher encounters an error of some sort like that, or if a file is renamed. So this very closely correlates to the watcher change enum type, watcher change types enumeration, but these are the actual events that are registered on the watcher. And so that's what we'll specify for the event name. So for the rest of this example, I'm going to use the changed event. So anytime that a file or folder is changed, we will fire an event. And then finally, we have the action script block here. And this is basically just an anonymous PowerShell script block that specifies the code that we want to run in response to any file change event. Now I'm going to use the PowerShell splatting syntax here because the line is getting a little bit long here. So what I'm going to do is just take these parameters and build a dictionary. I have a separate video that actually focuses on the PowerShell splatting syntax, but you'll see it basically here. So we create a dictionary with a bunch of parameters, and then we splat them onto our function that we're calling here, which is the built-in PowerShell register object event command. Now, one other thing I wanted to point out is that anytime that you have a .NET object like a FileSystemWatcher, for example, you can take that object and pipe it into the GetMember command. And GetMember is a type reflection command in PowerShell that allows you to look at the different properties, methods, and events that an object exposes, a .NET object exposes on it. So the watcher is currently null because we restarted our PowerShell session and that wiped out all of our variables here. So let's go ahead and just comment out line number 13 for now. Do F5 to run the script. And as you'll see, the getMember command actually prints out the events that we just looked at in the documentation for the FileSystemWatcher, along with the methods and properties on that object as well. So if you have an object that you think has some events on it, but you don't know exactly what those events are, you can just use .NET's type reflection with getMember to find out what those event names are. All right. So inside of our action handler here, the first thing we're going to do is just write out some text. Now, keep in mind that action handlers on events can be a little bit confusing to work with because they kind of run in their own isolated area of memory or something like that. I'm not quite sure how that works. But if you were to emit an object using like the write output command in PowerShell, it's not going to return that object to you in the same way that a function will return it to you. So if you need to do any kind of debugging inside of an action handler, it's typically, I've found the best ways to do it are to use the write host command. I know that there's a lot of people that don't like the write host command, but it is actually useful in this case because it forces PowerShell to actually write output to your console. So what we're going to do is do write host object something happened. And so this is just going to give us a really generic message that our changed event has fired. So let's save that and run the script. So that's going to register our event handler, which is represented here. And then you'll notice that immediately we get some events firing. Now I'm not quite sure why those fired because I don't think anything changed, or I don't think I intentionally changed anything right after that. However, if we create a new file, it should fire an event. Now it's not actually firing that event, so let's go ahead and find out what is happening here. Okay, and the reason it's not firing, I should have known this, is because we didn't register for the created event. We only registered for the changed event. So if I were to actually change the contents of that file, now we get something happened. Now, we're not going to talk about this immediately, but something I do want to call your attention to is that every time we make a change, 2 more events are happening, not 1. Now, that is a known issue. If you go out and look on Stack Overflow, there is a pretty well-trafficked item that talks about this issue. It's been viewed 126,000 times. It's got 322 upvotes, and people have different techniques on how to deal with this. I am going to talk through one example of how we can deal with this, however, in PowerShell. All right, so this is kind of the most basic example of an event handler. So we basically just said, do something, write some text, right? But this is not particularly useful. So what we want to do is turn this into something that's a little bit more useful. And the way that we can do that is actually by capturing some of the event metadata that's emitted by every event. So when you call register object event and you register for this event handler, you'll actually get an event object inside of this action script block. Now, the documentation for PowerShell over here under automatic variables, about automatic variables, talks about all the different built-in PowerShell variables that are available. And one of those is called $event, $event args, which is related, and $event subscriber. Now, the event args and the event subscriber are actually subsets of the event itself. So what we're going to do is just use the event itself and then dig into that object to retrieve the event arguments. So the first thing we'll do is do write host object, and then what we're going to do is take that event object and we're going to convert it to JSON and write that to the screen. So let's do function F5 and run that. And if I scroll up a little bit here, you might notice something. Our event subscription that we just created is actually event subscription number 2. So it has ID number 2. Now, what this means is that we actually have registered 2 different event handlers. So our first event handler has the something happened, and that is still active out there because we haven't restarted PowerShell and we also haven't explicitly unsubscribed it. So now we have a second event handler that is going to write the JSON of the event in addition to the something happened. So what we can do is we can either do a PowerShell restart current session, or even better, what we can do is called get event subscriber, and then pipe that into unregister event. And we'll do that before we call register object event. So every time we rerun the script, we're going to deregister all of the active event subscriptions, and then we're going to register our newest one. So let's save that and rerun it. And so now we only have one event subscriber that has our most up-to-date event subscription. So let's explore the JSON that's being output here. Now remember, we're getting 2 events. So what we need to do is basically find where the second event is starting and just focus on that one event. So this is event number 1 up here. Everything starting here is event number 2. So there's a lot of different properties available on each event. We have the run space ID, the sender or the object that basically triggered that event, which is our FileSystemWatcher, and all the properties on the FileSystemWatcher object itself. But most usefully, we have what is called the source event args. And the source event args basically allow us to see some specifics about the event itself. So we can see the path to the file, as well as the relative path to the file. So basically our root path is /root. That's the directory that we're currently operating in. And then this name here is the relative path to the file system path that we registered for, which is /root. And then you also have this change type here, and change type is 4. So if we were to go back to the documentation for Watcher change types enumeration, and we look at the different fields that are available on that enumeration, the 4 actually correlates to that changed event that we registered for on register object event. So what we can do is we can basically grab this path and say, okay, this path, this log file changed. And if you recall earlier, I was confused about why we got that event trigger right away. Well, it's because our debug adapter logs in PowerShell are actually getting updated anytime that we rerun our script here. So that's why we had that file system change get detected, even though we didn't explicitly change any files, because it was actually buried in our directory tree under our /root directory. So, all right, now we need to make our event handler a little bit more useful here. So what I can do is use some of that event data to kick off a script. So let's say that your project had a build folder, and inside that build folder, you had a build script like build.ps1. So this will recompile your project. It'll build your documentation. It'll upload some artifacts up to a repository somewhere. Maybe it'll build a Docker image and push a Docker image up to a container registry, something like that, right? You have some kind of build process that you want to execute. Maybe you want to even do something like send a tweet or send a Slack notification to your team or something like that. There's a whole bunch of different ways that you could integrate from this point forward. I'm just going to go really basic here and say build started. So I'm going to create a build script, and I'm basically just writing out build started. So now from inside my action here, I can actually grab the event and take a look at the event.sourceArgs here. And sourceArgs is actually a JSON array. So we actually have two objects, and in JSON, a square bracket indicates an array. And so this is item number 0 in the array, and this is item number 1 in the array. So in order to get the path to the file that is changed, we actually need to grab the full path property from sourceArgs item number 1. Which will get the second index in that array of items. So let's start by just echoing that out for a test. So we'll rerun the script. Okay, and now it's basically just echoing out that full path property. So now what we can do is we can say, let's assign that to a variable called full path. And now we can say if full path matches build.ps1, and then we'll anchor it at the end. So we'll say if it ends in build.ps1, then run the build script. So we'll say run full path. And the ampersand is the PowerShell operator to kick off a PowerShell script or an executable. Or you can use the dot. The dot and the ampersand have different meanings, but that's outside the scope of this particular discussion. So let's save that. And so now we'll rerun this. And so no events are occurring right now, but just keep an eye on the console down here. So if we come up to this build script and we say build started 2 and save that file, as soon as we save that file, instantaneously our build script is executed by the tasks handler. Now keep in mind that there are 2 events occurring, and we're going to take a look at how to handle this. So to take those 2 events that are occurring almost exactly at the same time, we need to deduplicate that somehow. And the way that we're going to deduplicate that is by creating a global variable called last run time. And we're going to make this an empty dictionary. And what this is going to do is it's basically going to take each file path. So let's say we had build1 and build2.ps1 and build3.ps1 and a bunch of different files, right? And we only want to run each file once within a 5-second period. We don't want it to run twice every time that we save the file. But if we've made a change and it's been at least 5 seconds or maybe at least 10 seconds, whatever interval you decide, then you want to basically kick it off again, right? So what we're going to do is we're basically going to add the last time that a file was written to this last runtime dictionary. And if it's been more than 5 seconds, then we'll go ahead and kick it off. So we'll say if global last runtime, and then we'll grab the element based on the full path name that we just pulled out of the event name here. So we pull the full path of the file out of the event, and then we basically query this to see if it has an item in the dictionary. And if it doesn't, so if we say if not, so you can do exclamation point or -not in PowerShell. So if it's a null value, then what we want to do is actually set that last runtime to date time now. So now we basically said the last time it was executed is now. So now we can say if the full path, or sorry, if the current date time, so if get date minus the global last runtime for this particular file. And then we have to wrap this. So this is actually going to give us a time span. So when you take a date time object and you subtract another date time object, then what's going to happen is it's going to give you a time span. And so the time span object has a total seconds property on it. So we can say if the difference between the current time and the last time that this particular file was executed is greater than 5, then do something. So we'll move this code that actually executes our build script into there. All right, so now what we need to do is say if we actually execute our build script, then we need to re-update this path to datetime now. And I think I've got this right here. It's a little bit confusing, but let's create a variable called timediff, and we'll actually assign the results of this to that variable. So we're basically getting the number of seconds since it last executed. And then we'll say if timediff is greater than 5. So that looks a little bit prettier. And then we'll echo out the timediff here just for debugging purposes. Let me just close my other editors here to clean this up a little bit. So now, in theory, this should work correctly. So let's see what our output looks like. So let's go ahead and change this build file. So we'll say build started 3. And it looks like it is not executing because our time difference is not correct. Now I'm going to cheat a little bit here. So I actually solved this problem already. And what I did is I basically said if the time difference is greater than X, then go ahead and run it. So it looks like my code is substantially the same here. Let's go ahead and change this file again. Okay, so now you can see what's happening is that my build started text is only getting echoed out once for every period, every 5-second period here. And it looks like I am running into some little issues here. And this could be because I'm actually running into an exception here inside my event handler that's not being exposed because it is running in that kind of isolated space. But you can basically use this technique to restrict how often your files are changing. So there again, build started 3 runs, and then if I wait at least 5 seconds, change it to something like build started 6. I'm not quite sure why it's not cooperating here. Okay. So it looks like maybe I'm not quite calculating this out right, but as you can see, it's no longer triggering that script back to back like it was previously anymore. It is actually waiting a certain amount of time before kicking off that build script too often. So I have to stop there because my time is about to run out on my memory card, but this is kind of the introduction to registering for object events that I wanted to show you and how you can watch for file system events and respond to them in PowerShell. If you liked this video, if it was helpful, if you learned anything new from it, please leave a like. Please, again, leave a comment and let me know what you think of my content, and we will see you in the next video. Cheers!